Hi all. Now we will study what is mathematical logic and why it is important in computer science. See, the name itself is telling you mathematical logic means logic for mathematics, right? You can also call it language for mathematics or language for mathematicians or language for computers, language for artificial intelligence, or you can say language for automated reasoning. So these are the different names. Basically you can say that these are the definitions or these are the ideas of what is mathematical logic. Mathematical logic means logic for mathematics, or you can say language for mathematics, language for mathematicians, language for computers, language for AI, artificial intelligence, and language for automated reasoning. Okay, we will see we will try to understand what this means basically. So let's see why we call it language for mathematics. We call it language for mathematics, this mathematical logic. Okay, we call it language for mathematics. Why? Because it gives, this mathematical logic gives precise and unambiguous meaning to all the mathematical statements or theorems. Whenever you have some mathematical statement or theorem, then that theorem, that mathematical statement must have precise unambiguous meaning. Okay, and this mathematical logic is used to give precise unambiguous meaning to mathematical statements or theorem. We will try to understand what this means, but before that let me ask you one question. You might be thinking that why do we need another language for mathematics? We already have many languages, many natural languages we have, like English, Hindi, Tamil, Telugu, Chinese, many natural languages we have. So why can't we use one of these natural languages for mathematics, for computers? But why do we need a new language? Why do we need a new logic for mathematics or computers? What is the need? Why can't we use the natural languages? Like for example, English, Tamil, Telugu. Why we can't use those natural languages for mathematics or for computers? So if you think about it, let me tell you the answer. The answer is because all the natural languages are ambiguous. All the natural languages that we have, okay, Hindi, English, Tamil, Telugu, Chinese, whatever natural language you take, that is ambiguous. So that is the reason we cannot use these languages for computers. Okay, we cannot use these languages for mathematics. So our answer is very simple, that these languages, these natural languages are ambiguous and we cannot allow ambiguity in computers, right? Okay, whatever command you give to some computer, that command must be unambiguous. There should be no ambiguity. Like if there is a robot and you want to give some command to that robot, then that command must be unambiguous. Okay, but natural languages are ambiguous. Now let's try to understand with some examples what is happening here. So you can see that, let me take the example of English language. Now English language is basically an ambiguous language. Okay, let me tell you that any natural language you can take here, but I'm taking the example of English. So English is basically ambiguous language, and let me explain with examples. So consider this statement. Read this statement and think about it. Is this true or false? Think about it. So the question is saying that, statement is saying that let a comma b be two integers. A comma b, these are two integers, and the statement is saying if a multiplied by b is even, then either a is even or b is even. Okay, so if you read this statement, think about it, pause the video, think about it. Is this statement true? This statement on your screen, a comma b are two integers, a multiplied by b is even, then a is even or b is even. Is this statement true? If you think about it, yes, this statement is true. So you can clearly see that this statement is true, because whenever two integers you multiply, if that is an even number, then at least one of them must be even, right? Okay, so at least one of them must be even. So I can say at least one of them must be even, right? So I can say that either a must be even or b must be even, correct? At least one of them must be even, either a must be even or b must be even. Okay, so this statement is basically true statement. But if you notice here, one thing you should notice that here this or basically means that either a should be even or b should be even, or both of them can happen, right? For example, let me call it p, let me call it q. In this statement, in this particular statement, please understand, in this particular statement, This or basically means that either P can happen or Q can happen or both of them can happen. P also can happen, Q also can happen, right? So you can notice that either A is even or B is even, or A comma B, both of them are even. So in this particular statement, in this English statement, this or word, this word means that either this can happen or this can happen or both of them can happen. Okay, so very simple. This is not a complicated to understand. You can easily understand this. So you can see that this is an English statement, and this statement is basically, I can say that this statement is basically true statement. And in this statement, this word or, this means that either this A is even or B is even or both are even. Correct? So in this statement, this or allows both of them to be true. Correct? Both of them to be true. Okay, so both of them also can be true, no problem. Now let's move on. Now let's see another statement. Consider this statement. Let's assume there is a missile system. Okay, in this missile system, you give a command in English language to this missile system. So okay, you are giving a command in the English language. You are basically saying that attack city A or attack city B. Now if you think about it, just think about it and tell me here, what do you want to say to this missile system? What do you want to say? What do you want to convey to this missile system? Basically, you want to convey that either you attack city A or you attack city B. One of them you attack, don't attack both, right? So this is what we want to convey. So please understand that. Let me call it again P, let me call it again Q. In this statement, this is an English language statement. Okay, this statement, if you note, this statement is an English language statement. In this statement, basically you want to say that this or, when you say this or, basically you want to say that either you attack P. If you are attacking city A, then don't attack city B. So either you attack city A or you attack city B, but don't attack both cities. But P comma Q, this should not happen. Like you are attacking both cities, this should not happen. So you can easily see, when you give this statement, in your mind you are thinking about this statement, you want to give this statement to the missile system, then what do you want to say? You basically want to say, this statement is English statement, but basically what you want to say is that either you attack city A or you attack city B, but don't attack both the city. One of the city you attack. Okay, so you can see that either this city A you attack. If you are attacking city A, then don't attack city B. If you are attacking city B, then you don't attack city A. One of them you attack, but don't attack both of them. This is what you want to say. Now you can easily see the ambiguity of English language. I told you that English is ambiguous language. You can easily see the ambiguity of English language, and that is, the ambiguity is here. See the ambiguity. These two statements have the same structure. Look at these two statements. In English language, these two have same structure. They have the same structure. Like basically you are saying something or something. So they have the same structure. If you notice, you are saying something or something. So these two statements in the English language, remember, they have the same structure, but still they have different meanings. Okay. In this first statement, this or allows, when you are speaking this or, then basically you are saying that this also can happen, this also can happen, both of them also can happen, right? Similarly, here when you say or, then you are basically saying that this can happen or this can happen, but don't do both of them. Attack city A or attack city B, but don't attack both of them. So you can see these two English statements, they have the same structure, but still they have different meaning, right? Correct? Okay, so same structure but different meaning, and that is the ambiguity of English language. Remember, you cannot allow ambiguity to the computers. You cannot give ambiguous statement to the computer. For example, this missile system, this is a, you can say this missile system, this is basically a computer. Okay, some computer. Now to this computer, basically, or I can say this is some program. Either you can call it computer or program, whatever. So to this missile system, you cannot give ambiguous statement. For example, this statement if you give, now this statement is ambiguous. Because you are thinking, when you are giving this statement to the missile system, you are thinking that either city A you attack or city B you attack, but don't attack both city. But this is what you are thinking. But what this missile system will think? This missile system can think, it is possible that this missile system can think that, okay, both are also possible. Just like in this situation. In this situation, you can notice this or allows both of them to be true. Okay. Both, this also can happen, this also can happen, both of them can happen. But you can notice that what I am saying, that so this missile system, it is possible that this missile system will think that, okay, this also I can do, this also I can do, both of them I can do. I can attack city A, also I can attack city B. Both the city I can attack. So that will bring disaster, right? So you cannot allow any ambiguity in the computers. Whenever you give some command, some statement, whenever you give to the computer, you cannot make it ambiguous. You cannot allow ambiguity. And you can notice the natural languages are ambiguous. So you can notice, if you allow this natural language, if you allow this ambiguity, then disaster will happen. Okay. So then you can notice that disaster will happen. Okay, disaster. This is a disastrous situation. So this is what I am saying, that finally, that English language is basically ambiguous language, and these two statements, they have the same structure, but still their meaning is different. And so that is the reason we study mathematical logic. I told you that mathematical logic means logic for mathematics, logic for computers. What is mathematical logic? This is logic. This is language for computers. And this mathematical logic will resolve this ambiguity. What this mathematical logic will do? See, what this mathematical logic is going to do? This mathematical logic will not give this statement to the computer. The mathematical logic, because here this or allows both of them to be true. Okay, either this can be true or this can be true, or both of them can be true. So what this mathematical logic will do, please understand this carefully. What this mathematical logic is going to do, you will not give this command to the computer. This command you will not, this English statement you will not give to the computer. Okay, to the missile system you will not give this statement. What you will do? You will give this statement. Basically you will give this statement. Let's call it P, let's call it Q. So you will give this statement P or Q. Now let me tell you that after some time we will see. Right now you might be thinking, sir, what is this symbol? What is the meaning of this symbol? So let me tell you, after some time we will see that this symbol allows both of them to be true. Okay, this symbol, look at this symbol. This symbol allows both of them to be true. It means P comma Q, both of them can be true. One of them can be true, both of them can be true. For example, this can be true, that is also correct. This can be true, that is also correct. And both of them can be true, that is also correct. So you can notice this symbol allows at least one of them to be true. At least one of them. Okay, at least one of them to be true. Both of them also can be true. So what you are going to do, this mathematical logic, remember, this is the mathematical logical statement. Please understand, this is mathematical logic statement. So what this mathematical logic will do, this will give this statement to the computer. Okay, this statement you will not give to the computer. This English statement you will not give to the computer. You will give this statement to the computer. So this is what I am telling you. So this is the mathematical logic statement. This is English statement. Please understand. This statement is English statement, but this is mathematical logic statement. Let me call it. So this is a mathematical logic statement. So this statement has no ambiguity. Okay. Similarly, if you want to give this command to the computer, to the missile system, then remember, this mathematical logic, it will not give this command, but what it will do, it will use this symbol. Okay. Like, for example, let me call it. For example, let me call it M. Let me call it N. Okay. Then in this situation, what you will do, the mathematical logic will use this symbol. So please understand that this symbol, what this symbol is, after some time we will see, but this symbol allows at exactly one of them to be true. Means if this is true, then this cannot be true. If this is true, then this cannot be true. Both of them cannot be true. Okay, one of them will be true. Exactly one of them will be true. Okay, so you can notice that mathematical logic, this mathematical logic will give this command to the missile system. to the missile system you give this command. Okay, so now this command you give to the missile system. So please understand that this command is unambiguous. There is no ambiguity. This is unambiguous. There is no ambiguity. But you can notice this English statement is ambiguous. This English statement is ambiguous. So English language has ambiguity. Same structure. These two statements, if you notice, this statement, these two statements, they have the same structure, but still they have the different meaning. So that is the ambiguity of English language, but this ambiguity is resolved by mathematical logic. This mathematical logic does not have any ambiguity. Okay, so that is the reason I am telling you that mathematical logic is the logic for mathematics. It is the logic for computer. It is the language of computer. It is the language of mathematics. Okay, because what it will do, this will create unambiguous and precise statements it will create. Okay, very simple. Now let's see another example. One example we have seen, but let's see another example. Another example where I will give you where I will tell you that this English is a ambiguous language. For example, consider this statement. Suppose your friend is saying the sun is shining and I am happy. Okay, so if you read this statement, do you feel any ambiguity? Just think about it. Read this statement. The sun is shining and I feel happy. If you read this statement, then you might be thinking that there is no ambiguity. Okay, the sun is shining and I feel happy. There is no ambiguity here. In this statement, there is no ambiguity, you are thinking. But let me tell you that if you think more carefully, then also there is some ambiguity. In this statement, there is some ambiguity. What is that ambiguity? See, please understand that. See, what actually this statement wants to say. What actually this statement wants to say. When your friend is saying that the sun is shining and I feel happy, what your friend want to say? What does this statement mean? Is your friend saying that he is happy because the sun is shining? See, right, read this statement. The sun is shining and I feel happy. Maybe your friend wants to say that his happiness is because of sun is shining. So you can see that maybe, I don't know, maybe your friend is happy because the sun is shining. So his happiness is dependent on sun is shining. Okay, maybe it is winter. In the month of winter, in the time of winter, maybe because sun is shining, so your friend is happy. Okay, so you can notice that from this statement, we don't know whether your friend's happiness depends on this sun is shining or not. Or maybe your friend is always happy. Basically, his happiness has nothing to do with sun is shining. Basically, these are two independent statements, right? So basically what it is, what do you think? See what I am saying, read this statement. This is an English statement, and if you read this statement, then there are two interpretations possible. Two different interpretations are possible. If one interpretation is that maybe your friend is happy because sun is shining, so his happiness depends on the shining of sun. But there or maybe it is possible that his happiness has nothing to do with the sun is shining. He is basically he's just giving the information that okay, the sun is shining, that is a different information, and I am happy, that is a different information. Maybe he is happy because of some other reason. Okay, so you can see that either your friend is happy because the sun is shining, or maybe sun shining and his happiness are completely independent things. Okay, so again you can notice, do you agree with me that again English is a ambiguous language? Again this statement, which looks very simple statement, okay, but this is also ambiguous statement. There is interpretation ambiguity here. Should I interpret like this? Should I interpret like this? Okay, so you can notice that again there is a interpretation ambiguity in this statement. So for example, consider this statement. Let's look at this statement. Cats are furry and elephants are heavy. Now in this statement actually there is no such ambiguity. Agree? In this statement you cannot say that okay, cats are furry because elements are heavy. In this you can clearly see these are definitely independent. Basically this information is independent and this information is independent. These two information have nothing to do with each other. You cannot say that elephants are heavy because cats are furry. No. So in this statement, you can notice that this and these two parts are completely independent. They are not dependent on each other. So again, this English is a funny language. Okay, English, or you can take any natural language. Any natural language is ambiguous. You can notice these two statements. Look at these two statements. They have the same structure. Look at these two statements. They have the same structure. In this also, you have some part and some part. In this statement also, you have some part and some part. So these two have the same structure. There is and here, there is and here. These two statements have the same structure. But still, you can notice that the ambiguity is possible. In this statement, there is no ambiguity. In this statement, you can say that yes, they are completely independent. But in this statement, you have ambiguity. So two statements in English language, this is the English language statements, they have the same structure, but still there is interpretation ambiguity. Okay, so that is the problem with English or any natural language. Whatever natural language you take, that is ambiguous. Okay, so you can notice two statements that are the same structure, but still they bring ambiguity of interpretation in the English language. So this ambiguity can be resolved by mathematical logic. Again, mathematical logic can resolve this ambiguity. Mathematical logic does not allow any ambiguity. Mathematical logic can resolve this ambiguity. What mathematical logic will do? See, mathematical logic will simply do this. What the mathematical logic is going to do? It will simply do this. For example, if this is A, if this is B, let's assume this is C, and let's assume this is D. What mathematical logic will do? Mathematical logic will simply say that, okay, A and B, and here also the mathematical logic will say that C and D. So you can notice now there is no ambiguity. Now you might be thinking, some of you might be thinking, sir, what is this symbol? What is this symbol? Don't worry, we will study this symbol. After some time we will study this symbol. What this symbol does? This symbol basically says that both of them must be true. Means this must be true, this must be true, this must be true, this must be true. Okay, so you can easily see that. Let me tell you, in this statement you can have some ambiguity. Please think about it. This is an English language statement. In this statement you can have some ambiguity. You may have some ambiguity, but in this you do not have any ambiguity. So you can notice this is an English language statement. In this you may have, it is possible that you may have some ambiguity. You don't know whether your friend's happiness depends on this or not. You don't know. So there can be ambiguity in this English statement, but this is a mathematical logic statement. But notice this is a mathematical logic statement. Okay, mathematical logic expression. In this expression there is no ambiguity. Similarly, this is mathematical logic expression. In this expression also there is no ambiguity. So this is the final conclusion, that mathematical logic resolves the ambiguity of natural languages. This is our final conclusion. Why mathematical logic is important? Now I hope you understood that mathematical logic is very powerful tool. Remember, it is very powerful tool. And what it does, it basically resolves the ambiguity of natural languages. Okay, so this is statement. So you can see the rules of mathematical logic, they specify the precise unambiguous meaning of mathematical statement. Okay, so if you are writing a statement, please understand that if you are writing a statement in mathematical logic, if you are writing a statement using mathematical logic, if you write some statement, for example, if I write like this, if I write some statement, then that is unambiguous. Okay, so this statement is precise. This statement has a precise meaning, unambiguous meaning. So this has a precise, unambiguous meaning. Okay, so this is the point, that mathematical logic, it gives precise, unambiguous meaning to the mathematical statements. Whatever English, like if you have this mathematical statement in the English language, you can convert this into a mathematical logic expression. Like this you can convert, and this mathematical logic expression, this expression is unambiguous. It gives the precise, unambiguous meaning to the mathematical statement, to the mathematical theorems. So this is the final conclusion. Now the second point, why we study mathematical logic, what is the another reason? The another reason, let me tell you, this is the another reason. This is, I can say, this is the second reason. The second reason is that this mathematical logic, this is the foundation, this is the basis of all mathematical reasoning and automated reasoning. What is automated reasoning? Think about it. What is the name itself is telling you? Automated reasoning means automatic. Automatic reasoning. So for example, nowadays, have you seen about, maybe you have heard about chat gpt. Okay, there is a software, or I can say, okay, there is a software that is chat gpt, right? Chat gpt. So you can notice this chat gpt, if you notice, this is a automated software. This is AI, or I can say, so basically this is automated. This is automated software. You can call it, this is automated program, or you can call it artificial intelligence, AI, whatever you want to say. So this is a automated software. Okay, what this software does, this is automated. Automated means it will automatically do all the things. So you can see that in this chat GPT, you give some information and basically you can ask some question. Okay, you can give some argument, some question you can ask, and it will give you the answer. Okay, right. So, so you can notice that this is the meaning of automated reasoning. Now, let me tell you that mathematical logic is the foundation, is the basis for all the mathematical reasoning and automated reasoning. For example, let me give you example. Consider these two reasoning. Consider these two arguments. So consider the following two reasoning, or I can say arguments. Which of them is valid? Like you have two arguments in front of you. Which of them is a valid argument? See, look at this argument, the argument number 1. Is this valid argument? Look at this argument and tell me, is this valid argument? See, this argument is saying that all men are mortal. So every man is mortal. Socrates is a man. Hence, Socrates is mortal. Is this correct? Is this argument correct? So let me tell you, yes, this argument is correct. See, you can notice that this argument is saying that, please read this argument carefully. This argument is saying that all men are mortal. All men, every man is mortal. Every man is mortal. Socrates is a man. See, Socrates is a man. Every man is mortal. Socrates is a man. And you can notice every man is mortal. So Socrates is mortal. Yes, that's correct. Okay. So you can notice this is a valid argument. This is a valid reasoning. Valid reasoning, or you can say this is a valid argument. What about this argument? Look at this argument. This is saying that all cats like fish. Every cat likes fish. Sylvie isn't a cat. Hence, Sylvie doesn't like fish. What do you think? Is this argument valid? See, this argument is saying that every cat likes fish. Every cat likes fish. Sylvie is not a cat. So Sylvie does not like fish. You can easily see, if you think about this, this is an invalid argument. This argument is invalid, and the reason is very simple. See, every cat likes fish. So if you are a cat, then definitely you like fish. But it does not mean that other people do not like fish. Yes or no? If you are a cat, then you like fish, but it does not mean that other people do not like fish. Sylvie is not a cat. Maybe Sylvie is a dog. Okay, maybe Sylvie is a human. So Sylvie can be anything. So you can see that every cat likes fish. It does not mean that other people do not like fish. Maybe Sylvie is a dog, and maybe Sylvie likes fish. It is possible that Sylvie likes fish. Okay, so we don't know. Remember, we don't know whether Sylvie likes fish or not. So we cannot say that Sylvie does not like fish. This is invalid. This is a wrong conclusion. This conclusion is, I can say, this is a wrong conclusion. This is a wrong conclusion. So finally, I am saying that this argument is valid. This argument is invalid. But see, here we are thinking about this argument. We are thinking about this argument, correct? Okay, you are a human being. You are thinking about this argument. You are thinking about this argument. But nowadays, what we want, what a computer science student wants. Tell me, what a computer science student does. Computer science people, what they do, they don't want. They want to convert everything into a program. They want to convert everything into an automatic machine. They want to create automated software for everything. Right? This is what computer science people do. Okay, they don't want, for example, they don't want to do multiplication. For multiplication, they will create a calculator. Okay, for whatever you want to do, okay, they will create a program. Either they will create a program or they will create a software. So the computer science people, Okay, whatever you give to them, they will try to create a automated software for that. Whatever problem you give to them, they will try to create a automated software. Now let me tell you that, so it will be very beautiful. Just think about it. Let's assume you have created an automated software. This automated software you have created, let's assume this automated software you have created, and in this automated software it will be so good, life would be so good, that if you give this argument, okay, this argument if you give, then it says valid argument, and if you give this argument, then it says invalid argument. Life will be very good. Yes or no? Because automatically your this automated software is giving you the correct answer. So this is called automated reasoning. What this software is doing, this software, what this is doing, this is basically doing the automated reasoning. And the same thing is done by the this chat GPT. Okay, I told you about chat GPT. What this does, it does automated reasoning. Okay, it will keep improving its knowledge. Remember, what you give him some information, you give it some information, you keep giving it some information, it will keep improving its knowledge. So it is basically doing the automated reasoning. This is what it is doing. And if you want to create this type of software, this type of automated software, if you want to create, if you want to do automated reasoning, then who is going to help you? Mathematical logic will help you. Okay, so this is what I'm telling you, that mathematical logic, this is the application of mathematical logic, that mathematical logic is the foundation or basis for all the automated reasoning and mathematical reasoning. So this is the reason this mathematical logic is so important. Okay, so these are the reasons. Like if anyone asks you what is mathematical logic, what is the answer? Let me give you the conclusion. What is a mathematical logic? This is a logic for mathematics, this is logic for computer science. Okay, you can say this is logic for artificial intelligence. And second point, so you can say that this is language for computer science, this is the language for computers, language for mathematics. Okay, and the reason why we want this logic, why we need this logic, because natural languages are ambiguous, but computers should not have any ambiguity. You cannot allow any ambiguity to the computer. So that is the reason this mathematical logic is very important. And what this mathematical logic do? Why this mathematical logic is important? This mathematical logic is important because first point is that it will give precise, unambiguous meaning to the mathematical statements. Okay, so using mathematical logic, if you write some statement, then that will be unambiguous, that will be precise statement without any ambiguity. So this is the reason, this is one of the reason why mathematical logic is so important. This is very powerful tool, remember, extremely powerful tool for computer science people. Okay, because it will give precise, unambiguous meaning to the mathematical statements. Whatever statement you make using mathematical logic, that statement will be unambiguous and precise. Second point, that mathematical logic is the basis for all mathematical reasoning and all automated reasoning. So these two, so this is what we have seen. In this lecture, we have seen that mathematical logic is very important. That is the reason this is in the GATE syllabus. Okay, so very simple thing. So I hope you understood what is mathematical logic, why mathematical logic is important, why we study mathematical logic. Okay, why it is so important for computer science people. I hope you understood that. Let me tell you one more thing, final thing. If you take any artificial intelligence course, if you take any AI course, any AI book, if you study, let me tell you, you can download any AI book, you can download artificial intelligence book, you can download. In that, let me tell you, the first chapter will be this mathematical logic. This mathematical logic is going to be the first chapter. So you can notice that it is so important. This mathematical logic, this will be the chapter 1. I hope this point is clear. So if you take any artificial intelligence course, if you take any artificial intelligence book, okay, then the first chapter will be mathematical logic. That is the importance of mathematical logic. It is so important. It is so important in the automated reasoning. I told you that artificial intelligence, that what it does, it is just automated reasoning. So I can say that this mathematical logic, this is so important for automated reasoning. This is the basis for automated reasoning. I hope that point is clear. So remember, this mathematical logic is the chapter 1 in any AI course, in any AI book. So because this mathematical logic is the basis for all automated reasoning. Okay, now how many type of what are the type of logics that we have? See, this mathematical logic, this is a huge field. Let me tell you that this mathematical logic, this is not a small field, this is a huge field. This mathematical logic, in this mathematical logic we have many different type of logics. We study in this mathematical logic, we study many different type of logics. Like the simplest type of logic that we will study, that is propositional logic. There is a type of logic, propositional logic. This we will study. There is another type of logic different from propositional logic. See, this propositional logic is one type of mathematical logic, or I can say it is subset of mathematical logic. So in this mathematical logic we have many different type of logics. One of them is propositional logic, another is first order logic. There are many more. For example, there is something called second order logic. There is third order logic, fourth order logic, and so on. There is another called fuzzy logic. So you can see that, and many more. So remember, simple point I am telling you, there are many different types of logics. These are different types of logic. So in this mathematical logic we have many different type of logics. Remember, each type of logic has its own definition, has its own, I can say, concepts. So this propositional logic has its own concepts, own definition. This first order logic has its own definition, concepts. This has its own definition, concepts. Fuzzy logic has its own definition, own concepts. So each type of logic has its own definition, its own concepts. Okay. Now in our GATE syllabus, what we have? This is what we have in our GATE syllabus. So we will only study propositional logic and first order logic. This is what we have in the GATE syllabus. This is what we have. So we will study, first we will study propositional logic, then we will study first order logic. This is what we have in the GATE syllabus. One more thing, let me tell you, once you go to MTech, in the MTech you will study this second order logic. Okay, once you go to MTech and you take artificial intelligence course, or if you take this discrete mathematics course, then you will study second order logic also, you will study. So I am just telling you that, remember, there are many different type of logics: propositional logic, first order logic, second order logic, third order logic, and so on. Like for example, fuzzy logic, and so on. So there are many different type of logics, remember. But in our GATE syllabus we only have propositional logic and first order logic. These two we have in the GATE syllabus. So we will first study this, then we will study first order logic. And now you might be thinking, sir, what is the difference between these two? What is the difference between these two? Like we will study these two, we will focus on these two, but what is the difference between these two? So that we will see. Don't worry about it. We will see what is the definition of propositional logic. We will see the definition of first order logic, and we will see their comparison. We will see how they are different, why they are different. Okay, which is more powerful, this propositional logic, first order logic? Which logic is more powerful? So all these things we will study. Okay, after some time we will study all these things. So don't worry about it. Now our next chapter is going to be propositional logic. So in the next chapter we will start propositional logic. So I hope everything is clear so far. So far we have seen what is discrete mathematics, why we study discrete mathematics, what we study in discrete mathematics. Okay, so introduction to discrete mathematics we have seen, introduction to mathematical logic we have seen, why mathematical logic is so important. Okay, why we study mathematical logic, why mathematical logic is very important to the computer science people. Okay, and what are the type of logic? There are many different type of logic, but in our GATE syllabus we only have propositional logic and first order logic. Now in the next lecture we will start propositional logic. Okay, thank you everyone.